Lesson 1.2, simplifying algebra expressions. So today we're going to be simplifying, which just means kind of combining like terms, distributing, that kind of stuff. And then we actually have to evaluate, meaning we have to plug in some numbers to actually find a value or get an answer for it. Then there's some word problems off of that. So let's jump right in. So the first part here says evaluate each expression for the given values of the variables. So the first one, our expression is x plus 3xy minus 2y, and then they tell me that I want x to equal 4, maybe, and y to equal 7. So I got to plug those in. So I'm going to basically have 4 plus 3 times, and actually I can probably get rid of that parenthesis, and just put parentheses around where I'm entering values in. Minus 2 times y, which is 7. Make sure you do order of operations correctly. Multiplication first. So this is 3 times 4 times 7. 12 times 7 would be 84. Bring the 4 down. 2 times 7 is 14. And now addition and subtraction are tied, so I just go left to right. So this would be 88 subtract 14 for a grand total of 74. All right, next one, we got some powers in here, some squares. So b equals 6, z equals 2. So I have 6 squared times 2, subtract 2 times 6 times 2, plus 2 squared. All right, so no big deal here. 6 squared is 36. 36 times 2 is going to be 72. Then I have some subtraction, but I got a chunk here. So I got to multiply all this together. 12 times 2, that'd be 24. And then I have addition, and then I got to do this power. 2 squared is 4. So technically, you're supposed to do powers first. So I should have did the 36 first, and then did this 4 over here. But then I was kind of going to go right into multiplication, so I just kind of did it as I went. 72 minus 24, that's 48 plus 4. So I believe 52. Yep, looks like what I have on my paper. Looks good. All right, moving right down, says we're going to simplify some expressions. So we need to clean things up a little bit. Be careful. I just want to say one thing about this previous section here. Be careful whenever you have a negative sign to put in place. So, for instance, let's say just pretend that this said z equaled negative 2. When you do this last portion here and you do z squared, you're going to punch that in as negative 2 squared, which in that case is going to be negative 2 times itself, which would be positive 4. If you just kind of jam it together and do that, do negative 2 squared, it's going to tell you that the answer is negative 4. All right? Because technically you're supposed to do this squared part first, which is 4, and then you just bring the negative sign down. So you do get different answers. So that's why I kind of like to get in the habit of putting my numbers inside parentheses, just so I don't screw it up later. All right, simplifying the expressions. Are there any like terms? Well, I have an x squared and a 7x squared. So that's really has a coefficient of 1 there that we don't see. So the 1 and the 7 make 8x squared. Then we just have the lone x term, plus 5x. And then we have this plus y term. And that's about as good as I can get. There's really nothing else that can be done there as far as simplifying. Over here, first thing I want to do is I want to multiply parentheses. So I'm going to keep it alphabetical. So I'm going to do like my a's, then my b's. So that'd be 5a squared b. And then I'm going to have a negative 2ab. And then I'm going to have the minus 11a squared b. And then plus the 2ab. And I'm going to try to gather some people up. So this is the a squared b family. This is also the a squared b family. So when I kind of combine those, I have 5 positives and 11 negatives, so that's going to be 6 negative a squared b's. And then when I kind of focus on what's left, I have negative 2ab's and then a positive 2ab's, which those are just going to cancel each other out. So final answer, negative 6a squared b. Number 5, Jamie's car can get 36 miles per gallon on the highway, 28 miles per gallon in the city. Write and simplify an expression for the total number of miles he can drive if his fuel tank holds 15 gallons of gas. So we want one expression that could figure this out. There's a couple different ways that we could do this. So let's just kind of think about it like this. If I can get 36 miles times every highway gallon, and then I'm going to add to that 28 miles times every city gallon, that should give me the total miles. So let's kind of just think about this over here. And we also know that a tank can hold 15 gallons. So let's look at the two extremes. Let's see if it was all highway. So if it was all highway miles, we would have 36 times 15, which that's going to be 360 and 180. So that's going to be 540 miles if they were all on the highway. So this is all if they were highway miles. Now, if they were city miles, I only get 28 times those 15 gallons, which would be 280 plus another 140. So I'm looking to get somewhere between 540 and 420, depending on how it's split up between highway and city. Well, there's another way to do this with just one variable. So what I'm going to attempt to do is I'm going to attempt to kind of rewrite this expression for total miles. But instead of using two variables, I'm just going to use one. So I'm going to say, well, there's 36 highway miles. Now, instead of using city, because I know how big the tank is 15 gallons. Whatever I choose for highway, the city is going to be 15 take away the highway miles. All right? So for instance, if I choose 10 for the highway, that's going to leave 15 minus 10, or 5, for the city. So that's kind of a slick little move, being able to write an expression where all in terms of one variable. So let's clean this up a little bit. So we have 36h plus, it's going to be 420 minus 28h. And if I simplify that down, I get an expression, the 36 and the minus 28 is going to be 8h plus 420. So I think that right there is a good expression in terms of h. So as long as I know the highway miles, I can kind of figure out what the car can do. Or highway gallons, I should say. So part B says, how many total miles can he drive on one tank of gas if he uses 5 for the highway? Well, 5 for the highway, so that'd be 36 miles times the 5 highway gallons. And then I should be able to get 28 miles for what's remaining, which is the other 10. All right, the other 10 for the city. And if we crank this out, we get 150 plus 30, that's 180 plus 280. So we should get 460 miles if we spent 5 of them, 5 gallons on the highway. And if I check that on my model right here, if I try this 5 gallons right in here, I would get 8 times 5 is 40 plus the 420. That also checks out to be 460 miles. So I just kind of come up with my own expression to represent that. That one was a little bit tricky. All right, number 6, our final one for these notes, says, write and simplify an expression for the perimeter. So remember, perimeter is we are adding up the outside lengths of this shape. So let's just go through. So we have A, and then we have 2B, And then we have an A plus B. Then we have another A. And then we have a 2A plus B. And then finally, we have a 2A. So I should have 1, 2, 3, 4, 5, 6 sides all represented there. Now we just got to go through, we got to collect everybody. So talking about the A's, I got 1, 2, 3, 4, 5, 6, 7, I believe, A's. And then if we go through our B's, we got 2, 3, 4 B's. So the expression that represents the perimeter there would be 7A plus 4B. And then if we wanted to, I'm not going to do that here, but we could take it a step further and be like, hey, you know, what if A equaled 5 and B equaled 2? And then you could go through and you could find out the perimeter by plugging those in. All right, the practice is right below. Hopefully these notes get you ready and will help you out when you're working on the practice. See you.